Hello. So we're going to move on to chapter 6. And this lesson is 6.1 Systems of Linear Equations in Two Variables. So, system of linear equations is any collection of two or more linear equations. Again, linear means straight lines. It has that word line in it. Okay, a solution set. For any system, the set of all possible points that satisfy every equation in the system. So for a system of two equations in two variables, these solutions come as ordered pairs. An ordered pair means x, y. For a system with three variables, the solutions will be ordered triple x, y, and z. Okay, so we've got three possible solution sets. When we have one solution, it looks something like this. So we've got two lines here, and they intersect each other at point x, y. So one solution means intersect. These are also called consistent, and they are independent. Okay, next possible solution set is no solution. Those lines look like this. So they never cross each other. So the lines are parallel. They are inconsistent. And they are independent. Next one is infinitely many solutions. So that's our third option. And that means that we have a line like this, and then we have another line that is on top of that line. So infinitely many solutions means that we have the same line. This one is consistent, again, just like the one solution, and this one is dependent. Okay, so let's go ahead and look at this next example here. Is 7, 6 a solution to this system? So we have two equations here, and we've got two variables. We have x and y. So what we're going to do is we're going to go ahead and plug everything in to the first equation. So our x is 7, so 2 times 7 minus 3 times 6. And this should equal -4 if this ordered pair is a solution to this equation. So 14 minus 18 equals -4. Yes, -4 on the left and -4 on the right. This is true. Okay, we can't just rely on one. We need to try the other one as well. So 2 times 7, so the same ordered pair, but we're taking the second equation. 2 times 7 plus 6 equals 4. So 14 plus 6, well, 14 plus 6 is 20. That does not equal. So this is false. So our answer to the question, is 7, 6 a solution to the system, is going to be no, because this one was false. All right. Let's move on and look at three methods to solve a system of equations. So we can solve system of equations graphically. It usually takes a lot longer to graph. And it is sometimes difficult to see an exact solution from the graph. So for example, if our solution is negative 1/5 and 2/3, which it can be, this would be hard to read from the graph. So graphing is not, you can always check with by graphing, but that's not the most um, suggested one to do. Now, the next method for to solve a system of equations is substitution method. So we're going to narrow the equation down to one variable by substituting in an expression from the other equation. So if we look at this example here, we already have this second one set as y equals 3x. So what we're going to do is we're going to take this 3x and plug it in where the y is on the first equation, on the top equation. So we're going to rewrite it x plus, and instead of the y, we're going to write 3x equals 4. So 4x equals 4. We divide by 4 to get x equals 1. Now we need to go ahead and plug this 1 back in to get our y. So I'm going to use the bottom one, y equals 3 times 1. So our y is 3. So our solution is going to be 1, 3. So we have one solution for this. Remember on this first page here, when we looked at one solution, um, so the point is 1, 3 for that. It is consistent and it's independent. So these are consistent and independent. Okay, let's look at this next one here. We've got 3x minus y equals 6 and 6x plus 5y equals negative 23. So this one is not as easy. We don't have y equals or x equals like we had in the previous one. So what we need to do is we need to solve one of these for y. So I'm going to take the top one because it it's easier because we only have a negative in front of it and then there's a 1. So that one is easier to solve for y. So 3x minus y equals 6. What I'm going to do first, or there's a couple of ways of doing this. Um, so we're solving for y. So this one right here. So we want to move the 3x to the other side. So we get negative y equals negative 3x plus 6. Now we have the negative 1 still, so we're going to divide by negative 1 all the terms, and we get y equals negative 3x minus 6. Actually, that's a plus because we've got the two negatives here that make a plus. So we get y equals 3x minus 6. Now we have the y, so what we're going to do is we're going to plug this in where we have the y right here. Okay, so 6x plus 5 times, and instead of the y, we're going to write the 3x minus 6 inside parentheses, and this is going to equal negative 23. So now what we're going to do is we're going to solve for x. We're distributing first. 6x plus 15x minus 30 equals negative 23. 6x and 15x are like terms, so we can combine those. We get 21x minus 30 equals negative 23. We can add 30 to both sides. 21x equals 7. And then we're going to divide by 21. So x is going to be 7 over 21. That simplifies to 1/3. We can divide both by 7 to get 1/3. Okay, so now we got our x here. Now we need to go and plug it back in. What we want to do is plug it back into one of the original equations. Why do we do that? We do it so that in case we made a mistake, for example, here, we're not making another mistake again. So it's just easier to go ahead. So I'm going to use that top equation, the first one, so 3 times, and now the x is going to be 1/3 minus y equals 6. Well, 3 times 1/3 is going to be 1, so 1 minus y equals 6. We subtract 1 from both sides, we get 5, and then we divide by -1, we get -5. So our answer is going to be our x coordinate is 1/3 and our y coordinate is -5. So again, we get an ordered pair as our answer. So there's one solution. This is consistent and independent. Okay, let's look at this next one here. Same thing. We're going to have to solve for y for one of them. I'm going to go ahead and take this first one here. So 3x minus y equals 9. Because the coefficient is -1, it's easier than when we have a 2 or a 6. We could solve for x as well if there was if the coefficient for x, the number in front of the x was 1. Um, that's totally fine. It doesn't matter which one. It's just easier to solve for the y right here because it only has that negative in front of it. Okay, so the same thing, we subtract 3x from both sides. We get -y equals -3x plus 9. We divide by -1, and so we flip the signs. And we get y equals 3x minus 9. Okay, we're going to go ahead and take that second and plug the y in it. So 2 times, and instead of the y, we're going to write 3x minus 9 minus 6x equals 7. Distribute. 2 times 3x is 6x. 2 times -9 is -18 minus 6x equals 7. Well, combining like terms, they're opposite, so they cancel each other out, and we end up with -18 equals 7. Well, that is false. So this means no solution. And so when we have no solution from here, we can see that they're parallel, inconsistent, and independent. So these lines are parallel, inconsistent, and independent. Okay, let's look at this next example, fractions. Yay. Now, for this one, we don't have one that is easier than the other one. There's not a one that has just um, x and y, the coefficient as 1. So we've got a couple of options, but what we're going to do is I'm going to go ahead and use this. Actually, that's the first one, and this is the second one. The second equation and solve for y because the y is already on the left. So all we do is divide by 4. We get y equals 3x plus over 4 plus 3. So now we're going to use this and plug it in to the y right here. Okay, so that first one is going to be a half x minus 2/3, and our y is 3x over 4 plus 3. And all of that equals -2. Okay, so half x, we're distributing here. 2/3 times 3x over 4. The 3's are going to cancel out, and then when we're multiplying by these, we can divide by 2, that becomes a 1, and 4 divided by 2 is a 2. So we get half x. Then we distribute it to the 3. Again, the 3's cancel each other out, and we end up with negative or -2, and this equals -2. Well, see what happens. These cancel each other out, and we end up with -2 equals -2. Well, that is true. So since this is true, it means that we have infinitely many solutions. So what did this mean? It meant that we have the same line. So both of these lines right here are the same. So they go on top of each other if we graph them. And then it's consistent and dependent. Okay, the third method here, how to solve, is addition method. Um, that is, I've seen also it being called elimination method. So those two are the exact same thing. I feel like the newer books use the elimination method, or newer curriculums. So that is when you add two equations together, you may need to multiply one or both by some coefficient to eliminate a variable. That's where the elimination comes from. So you are basically creating an equivalent system, what we're doing here. Now, looking at our first example here, so what we're looking at is we want opposite coefficients, either on x or y. Now, for the y, we can see that we have a negative y and we have a positive y. So these already cancel each other out, so we didn't have to multiply at all. So what we're just going to do is we're going to add. 3x plus 2x is 5x. Well, the y's cancel each other out, and 9 plus 1 is 10. We divide by 5, and we get x equals 2. That's our x. Now we go back in, just like we've done, and plug in the x equals 2. I'm going to use that, and it doesn't matter which one we use. I'm going to use the first one now. So 3 times x is going to be 2 minus y equals 9. So 6 minus y equals 9. We move the 6, so we subtract 6 from both sides. We get negative y equals 3, and then we divide by -1, so we get y equals -3. So we get an ordered pair. 2, -3 is our solution for this one. Again, it's consistent and independent. Okay, let's look at another example here. Now, looking at those two, we don't have a situation like we had in this first one where the y's cancel each other out by the coefficients. So we are going to have to multiply one of these, and it doesn't matter if it's the x or the y. I'm looking at the 4 and the 2. So To get a 4 here on the second one, it would be easy to multiply by a 2. And now we need the opposite, so we're just going to multiply by negative 2 this one. So negative 4x plus 6y equals negative 14. So what I did is I multiplied this whole thing by negative 2. I'm going to take this, so this, hold on. This is our first one, and this is our second equation. So our second equation is here. I'm going to write the first one down below it. 4x plus 5y equals 3. I did not make any changes to it. It's just like it is. I'm going to add. These cancel each other out. 6 plus 5 is 11y. Negative 14 plus 3 is negative 11. Divide by 11. And y equals negative 1. And now, again, we go and plug it back in. Make sure that you plug it back in one of the original ones. So we're going to take the first one and plug it back in there, 4x plus 5, and now y is going to be negative 1 equals 3. 4x minus 5 equals 3. We add 5 to both sides. So 4x equals 8, and we divide by 4. X equals 2. So our ordered pair, our solution is 2, negative 1. Again, this is consistent and independent. So now feel free to pause the video and try these 3 on your own. So I'm going to keep going here. For this next one, we have a 2x and a 3, 2 and a 3 here, and we have a negative 3 and a negative 2 for the coefficients of y. So we can't just multiply one. We're going to have to multiply the other one as well. What I'm going to do is I'm going to multiply the top by negative 3 and the bottom by 2. So I'm looking at the 2 and 2x and 3x, trying to get those the same. So when I multiply the top one by negative 3, I get negative 6x plus 9y equals 6. The bottom one is going to be 6x plus 4y equals 24. I add the negative 6x and plus 6x cancel each other out. 9 plus 4 is 13y, and 24 plus 6 is going to be 30. Hold on, I made a mistake somewhere. This should, okay, there's a negative here, so this should be a negative instead. I was like, those numbers shouldn't be. So it's 5y. Divide by 5, y equals 6. So now we take that y equals 6 and plug it back in to one of the original ones. I'm going to take that first equation and plug it back in there. 2x minus 3 times 6 equals negative 2. 2x minus 18 equals negative 2. I add 18 to both sides to get 2x equals 16. Divide by 2. X equals 8. So our ordered pair is 8, 6. That is consistent and it is independent. Okay, next one here. We've got decimals. So the same thing, we need to make sure that we multiply so that we get the opposite coefficients. Now, I want to get rid of those decimals, so I'm going to go ahead and multiply this top one by 10. So I get 2x minus 4y equals 5 when I do the multiplication. Now, looking at this, I want to multiply the bottom one by negative 2 to see if I can cancel the x's out. So I get the opposite coefficient here. Negative 2 times negative 2 for the y is going to be plus 4y. And then negative 2 times 1.3 is going to be negative 2.6. We're going to add, well, these cancel out, so that's going to end up being 0 on the left. And on the right, we get 2.4. Well, that's not true. That is false. So that means that we have no solution. Now, another way of saying no solution is an empty set, which is a 0 with the line on top of it. So our lines are parallel. These are inconsistent and independent. So again, every single time you get false, it's going to mean no solution. Okay, let's look at our last example here. So what I'm going to do here is, in order to make this a 3, so opposite of what we've got down here, I'm going to multiply it by 6, the top one. And that way I get rid of those fractions as well. So 6 times a half is 3x. Negative 2/3 times 6 is going to be negative 4y, and negative 2 times 6 is negative 12. The bottom one is going to stay the same as it is, and we're going to add, well, 0 plus 0 equals 0. This one is going to be true. So that means that we have infinitely many solutions. So every single time you get a true, that your answer is going to be infinitely many solutions. Another way of writing infinitely many solutions would be, we're going to write it as a set, and we're going to put xy, ordered pair xy, the straight line, that's not a straight line, a straight line across, that means such that, so xy are such that, and we're going to pick one of these original equations. It doesn't matter which one we do. So I'm going to do the bottom one, negative 3x plus 4y equals 12. I could have picked the top one as well. This is the same thing as the infinitely many solutions, just another way of writing it. So these are consistent and they are dependent because they're the same line. Remember that infinitely many solutions, when we get that true, it is the same line. Okay, that's it. Oops, that was not what I meant to do. That's it for this lesson. Let me know if you have any questions. Bye.